Hi students, in last class you have learned about the definitions of derivative, that is differential coefficients at some point. Today we will learn the properties of derivative. The properties of derivative: if fx and gx are two functions and c1 and c2 are two scalars, then c1 fx c2 gx plus or minus, that is linearly combinations of fx and gx, and derivative of c1 fx plus or minus c2 gx, this equal to ddx of c1 fx plus or minus ddx of c2 gx. This equals to c1 ddx of fx plus or minus c2 scalar ddx of gx, ddx of c1 fx plus or minus c2 gx. This formula, this is very important part, that is the derivative of different function can be split up into different terms. Suppose ddx of 2x square plus log x plus e power x, 5e power x, suppose. Then we can write this ddx of 2x square plus ddx of log x plus ddx of 5e power x. This is constant, can be taken outside. ddx of x square plus ddx of log x means 1 by x. 5 constant can be taken outside. ddx e power x. Derivative of 2x square is 2x plus 1 by x plus 5. Derivative of e power x is e power x. I have given the formula in last class. Then this is equals to 4x plus 1 by x 5 e power x. This is the derivative. Now ddx of fx into gx, that is derivative of product of two functions. This equals to fx into ddx of gx plus, keeping gx as same, ddx of fx. This is called product rule. Product rule. If we apply this, find ddx of, suppose, x square log x. There are two functions. This x square, suppose x square is fx, and log x. Log x is another function. You can take as gx. Then this equals to, applying this formula, x square into ddx of log x plus, keeping log x constant, log x ddx of x square. Derivative of log x 1 by x, log x into derivative of x square is 2x. Then this equals to x plus 2x log x. x plus 2x log x. This is product rule. Now quotient rule. ddx of fx divided by gx. This equals to gx, denominator contains gx whole square, keeping gx as same, ddx of fx minus, keeping fx, ddx of gx. This is another rule, is called quotient rule. Quotient rule. Now, if we apply this in an example, ddx by x log x, suppose, then this is fx is x and gx is log x. Then this equals to log x whole square, gx whole square, gx means log x whole square. Now gx means log x, ddx of x minus fx means x, ddx of log x. This equals to log x, logarithm of x, derivative of x with respect to x is 1. Now x, derivative of log x, 1 by x by log x whole square. This equals to log x minus x cancel, 1 by log x whole square. This is the derivative of x by log x. Now, suppose A, B and C are three non-empty sets. Let G be a mapping from A to B and F be a mapping from B to C. G maps from A to B and F maps from B to C. Suppose here is a point X in the set A. Then by the mapping G, X corresponds to Gx. Gx belongs to the set B. And by the mapping F, Gx is also corresponds to F of Gx. F of Gx. If we directly we can directly get f of gx from the point x by the combinations of the two mappings g and f, and it is denoted by f composition gx. F composition gx. This mapping is f composition g corresponds from maps from A to C, and it is defined by f of gx. This is so f composition g of x equal to f of gx. Obviously, f composition g is a mapping from A to C. F composition g is a mapping from A to C. Now, that is here, this is called composite mapping or mapping function of functions. F composition gx, f of gx. Now, ddx of f composition gx. This means ddx of f of gx. This means limit h tends to 0 f of g x plus h minus f of gx by h. From the definitions of derivative, limit h tends to 0 f of g x plus h minus f of gx. We know f dash x equal to limit h tends to 0 f of x plus h minus fx, f of x plus h minus fx by h, f of x plus h minus h. So here f of derivative of function of f of gx is f of gx plus h minus f of gx by h. We can write this limit h tends to 0 f of g of x plus h minus f of gx divided by g of x plus h minus g of x into, we take here extra g x plus h minus gx, so we take here g x plus h minus gx such that this will cancel. Then h equal to limit h tends to 0 f of g of x plus h minus f of gx by g of x plus h minus g of x into limit, split the limit into two parts, g x plus h minus g of x by h. Then this equals to derivative, this equals to ddx not dd of gx f of g of x, and this equals to ddx of gx. We can write this, so this equals to ddx of f of gx equal to this. This rule is called chain rule. Chain rule. It's called chain rule. Therefore, we have found ddx of f of gx equals to dd g, symbolically write df dg with respect to g into dg df. G means g of x, f means f of gx. G means g of x and f imply sorry, we write here full form ddgx of f of gx into ddx of gx. If we write gx equals to u, gx equals to u, then we can write here ddu of f of u. This means ddx of u, that is f dash u into du dx. ddx of f of u, where u is the function of u equals to gx, function of gx. This is chain rule. Now, if we apply, find ddx of e power sin x. Obviously, here are two functions. One is exponential functions, another is trigonometric functions, sine functions. Exponential function, sine function. That is here compositions of two functions. Compositions of two functions. So we can write this ddx of dd of sin x with respect to e power sin x, gx is sin x, into ddx of sin x. Then the derivative of e power sin x with respect to sin x, e power sin x, derivative of sin x is cos x. We can do derivative in the another way, e power sin x. Let sin x equal to u. If we derivative du dx, then derivative of sin x with respect to x is cos x. Then this y equals to e power u, sin x means u, then y is a functions of u. From this we can calculate dy du. Since y is a function of u, dy of y, this equals to e power u, derivative e power u means sin x. So by chain rule we have to find out dy dx equals to dy du into du dx, same rule. Then dy du means e power sin x into du dx means cos x, same result. Now find out ddx of log of tan x. Simply, we first consider the function's log. Derivative of log x means 1 by x, then derivative of log of tan x with respect to tan x means 1 by tan x. First you consider the function's log. Derivative of log 1 by, derivative of log x 1 by x, derivative of log tan x 1 by tan x with respect to tan x 1 by tan x. Now we consider the derivative of tan x into ddx of tan x is equals to 1 by tan x. Derivative of tan x means sec square x, that is sec square x by tan x. ddx of root over fx, suppose. Then first we will consider the square root functions. We know ddx of root x means 1 by 2 root x. ddx of root x means 1 by 2 root x. Root x means x power half. ddx of x power half means half x power half minus 1. Half minus 1 means minus half, minus x power minus half means 1 by x power half, that is root x. Therefore, ddx of root x is 1 by 2 root x. Always remember this, ddx of root x is 1 by 2 root x. Then ddx of root fx, we have to apply chain rule, 1 by 2 root fx, considering the root fx as single functions x. Then you consider the derivative of fx, f dash x. So if you keep remember ddx of root fx equals to 1 by 2 root fx into f dash x. So ddx of root over x square plus 5x plus 6, then this equals to 1 by 2 root fx means x square plus 5x plus 6 into derivative of this, derivative of x square 2x plus derivative of 5x 5 into 1, that means 5, and derivative of 6 is 0. Therefore derivative of root over x square plus 5x plus 6 is this. ddx of fx whole power n. Here is two functions, power functions. So we first consider this is a single variable fx. If we take fx as u, then u power n. Then derivative of u power n u power n minus 1. U means fx whole power n minus 1 into derivative of fx f dash x by chain rule. This is another formula. So ddx of ax plus b whole power n, this is equal to n ax plus b whole power n minus 1 into derivative of ax plus b, ddx of ax plus b, n ax plus b whole power n minus 1, ddx of a plus b means a into derivative of x means once, a into 1, that is a, and derivative of b is 0, that is this equals to n ax plus b whole power n minus 1. Now, if y equals to e power sine ax square plus bx plus c. Consider these functions. Here are three functions. First exponential functions, then trigonometric functions, then algebraic functions. So we have to first consider exponential functions. So when you find out derivative dy dx, then derivative of e power x is e power x. Then derivative of e power fx is e power fx into f dash x. So derivative of this is e power sine ax square plus bx plus c into ddx of sine ax square plus bx plus c. Remember, ddx of e power fx means e power fx, if you take fx as u, then e power u, derivative with respect to u is e power u. So it is e power fx into f dash x by chain rule. So e power sine ax square plus bx plus c into, here also two functions, one is trigonometric function, sine function, and another is algebraic functions. So derivative of sine cos ax square plus bx plus c into derivative of this ddx of ax square plus bx plus c. Now this equals to e power sine ax square plus bx plus c into cos ax square plus bx plus c into derivative of this ax square, a into derivative of x square 2x, a into 2x, that is 2ax, derivative of bx, b into 1, derivative of x is 1, that is b into 1, that is b, and c, derivative of c is 0, c is constant. So this is the derivative. Now there are two types of functions by representations. One is explicit functions, another is implicit function. Explicit functions is of the type y equal to fx, here y is subject, and implicit functions fx comma y equal to c. Sometimes implicit functions can be expressed as explicit functions, and sometimes it is very tedious to represent as explicit functions. So we have to find out now the derivative of implicit functions. Explicit functions, what have we have done earlier, all are explicit functions. Now the implicit functions. Suppose implicit functions 3x square plus 2xy plus y square equals to 5. Like this. This is implicit functions. We have to find out dy dx. Dx of y. We have to find out. So from this differentiating with respect to x. Now derivative of 3x square with respect to x, ddx of 3x square plus ddx of xy plus ddx of y square equals to ddx of 5. This means these constants you can take outside. Then ddx of x square means 2x. Derivative of x square 2x. Now this is product x into y. Keeping x as constant, derivative of y is dy dx. Sorry, here was 2xy. 2 take outside. Now ddx of xy. Keeping x constant, derivative of y dy dx plus y into ddx of x. ddx of x means 1 is plus here the functions is of y, but derivative is with respect to x, so we have to make chain rule here. So we can write this dy of y square into dy dx by chain rule. When the functions is of one variable where the derivative is with respect to other variable, then we have to apply chain rule. So we have to make here, since it is the functions of y, so we have to make it dy function of y, so we have to make here y. So dy y square into dy dx. This equals to derivative of 5 is 0. This equals to 6x plus 2x dy dx plus 2y plus derivative of y square now with respect to y is 2y into dy dx equals to 0. From this 2 we can take ddx of y. So here 2x plus 2y. This equals to plus 6x, it will be minus 6x plus 2y, it will be minus 2y. This equals to the imply ddx of y equals to minus, take common 3x plus y by 2, take as common x plus y, 2 to cancel, minus 3x plus y by x plus y. This is the derivative of implicit functions. Now, parametric functions. Derivative of parametric functions. Suppose x equals to ft and y equal to gt. T is parameter. That is when the two variables x and y explicitly are functions of another variable t. Here t is called parameter. Parameters means independent constants. T can be take any real value. Take as any real value. So t does not depend on another variables. T is independent constant. So indefinite constant or independent constant. So from to find out dy dx, we have to find here ddx of y, ddt of x. Sorry, ddt of x. We can derivative differential coefficient of x with respect to t. Since x is a function of t, equals to f dash t, and ddt of y equal to g dash t. So we have to find out dy dx. This means dy dt into dt dx, chain rule. We can write dy dt divided by dx dt. Dt dx means 1 by dx dt. This is equal to dy dt means g dash t by f dash t. Therefore dy dx equals to g dash t by f dash t. Dy dx in parametric functions. Now observe that dt dx equal to 1 by dx dt. Why? Why dt dx equals to 1 by dx dt? This is the questions. Suppose y equal to fx is a functions and its inverse functions is x equal to gy. Inverse function is x equal to gy. From this, here y is subject. From this function we can take x as we express x as subject and x is the functions of y. So then g composition of fx. This means g of fx. This means g of fx means y. G of y. This means gy. Gy means x. That is g composition fx equal to x. This implies g composition f is identity function. Identity function, because g composition fx equal to x. G composition fx is identity functions. Thus g composition fx means you have already know g of fx. G of fx equals to x. Then differentiating with respect to x, ddx of g of fx equals to derivative of x is 1. Derivative of x is 1. Now ddx of g of fx means df ddfx of gx by chain rule, g of fx into f dash x. F dash x means ddx of fx equal to 1. Now fx means we write y equal to fx. We wrote y equal to fx, y equal to fx, y equal to fx, and its inverse is x equal to gy. So then fx means y, g of fx means y into ddx of fx means y equal to 1. dy. gy means x into dy dx equal to 1. So dy dx equals to 1 by dx dy. So we can write this dy dx equals to 1 by dx dy. Now a simple example, x equals to a theta plus cos theta and y equals to a 1 minus sin theta. Find out dy dx. From here we can find out dx d theta. Theta is parameter. A derivative of theta means 1 and cos theta derivative of cos theta sin theta. And again dy d theta of y, a derivative of 1 means 0 constant and sin theta derivative cos theta. This means minus a cos theta. Therefore dy dx dy d theta divide dx d theta. Dy d theta means a cos theta divided by a 1 minus sin theta. This means a cancel minus cos theta by 1 minus sin theta. This is the derivative of parametric functions. So this is the second part of differential calculus. Differential calculus is very vast subjects, and the next class we will learn more about differential calculus. Thank you.